Hey, what's up? Let's just have a quick moment of silence for the number Googleplex, because after this video, you're gonna have a new big number to think about. Okay, let's get started. So how big is Graham's number? Well, we have a arrow b, which is just another way of writing a to the power of b. So how does the arrow notation work? Well, say I have 3 so what this means is that I'm going to, 5 times, I'm going to write down the number 3. So I'm going to write down 3 5 times. So that's what the number on the right here says. And then what goes in between them? Well, arrows, but just one less arrow than we start with. That way we don't just kind of get caught in an infinite loop getting like to an infinitely big number. We're actually kind of getting smaller, or not smaller, sorry, but yeah. So that's how it would work. So let's start with 3 Well, that's 3 arrow 3 arrow 3. Now we always go from the right side to the left side. If we just went from left to right, we're just making our base number bigger. We're making the number that appears bigger each time. But when we go from the right to the left, we're actually creating more repetition that way. So what is this number? Well, 3 arrow 3 is 3 to the power of 3. And then 3 arrow all of that would be 3 to the power of all that. So it's a tower of height 3, okay, which is about 7.6 trillion. Now let's take a look at 3 triple arrow 3. Well, I'm going to copy down 3 times, and with one less arrow between them all. So what are we going to get here? Well, this is 3 double arrow. What is this thing? Well, we just went over it earlier. It's about 7.6 trillion. We'll say this is about, okay? So what is this? Well, this is going to be a exponential tower of 3, 7.6 trillion high. So let's go kind of like that. 7.6 trillion approximately 3s in this tower. So what kind of a number are we talking about here? We'll say I filled this page with 9s, right? I wrote down 9 from the corner to the corner to write, you know, a really big number, right? And then say someone came along and they gave me that number of pages, which of course would collapse into a black hole, but just say it kind of worked out for me. So then they gave me that number of pages, and then say I filled all of those pages with 9s to create a gargantuan number. And then they say they gave me that number of pages of that gargantuan number I just wrote down. And then I fill all of those with 9s, and then they give me that number of pages, and I fill all of those with 9s, and they give me that number of pages. And this keeps going about 7.6 trillion times. Well, that's the number that we're talking about right here, approximately. So what happens if we go even further to 3 quadruple arrow 3? Well, now we got triple arrows between them. So we're going to have 3 copied down this number of times. So when I write down all of this, how many 3s are appearing in here? This many 3s are appearing in there. And now instead of single arrows between them, I have double arrows between them. So what kind of a number are we talking about here? Well, we start with 3, and then we create an exponential tower 3 high. And then this number is about 7.6 trillion, so we'll create an exponential tower about 7.6 trillion high. And this is that gargantuan number that we talked about earlier, but now we're going to create an exponential tower that's this high, and then we're going to create an exponential tower that's that high, and we're going to keep doing that. And how many times are we going to do that for? This number of times. So this number is truly crazy. So now we have G1, which I'll define to be 3 quadruple arrow 3. So we see that adding another arrow gives us a much bigger number, right? So now you're not thinking about increasing the size of this number or this number. I know how you're thinking. You're thinking, how many arrows can we cram in there, right? How many arrows do we want to put in there? Well, what's the biggest number we've thought of so far? It was this number, right? G1, that gargantuan, extra gargantuan number. So let's put in G1 number of arrows between the 2 3s. Now G2 is a completely different kind of number from G1. Even writing down all these arrows, you'd have to write down G1 arrows, and that is just, yeah. So then G3, how are we going to define that? Well, we'll put in G2 arrows in between the 3s, and then G4 will have G3 arrows, G5 will have G4 arrows, and then we get to G64, which is going to have G63 arrows between the two 3s, and that is Graham's number. So, how big is Graham's number? Well, if you think about it, you could write down the formula for Graham's number without very many symbols. So while it's a very big number, the idea of it is quite small. If you want to hear about even bigger numbers, feel free to ask me, because this stuff is a lot of fun and stuff. I'm gonna just stop. So, thanks for watching. Goodbye.